Hello, welcome to my class. This class is for class 9 and in this video we are going to discuss question number 567 from exercise 8.2 from the chapter quadrilaterals. And if you have not subscribed to my channel, please subscribe and do like the video if you like my class and share it with your friends. Do not forget to click the bell icon to get notifications also. If you have any doubts, you can ask that as comments. If you want any questions as videos, you can ask that also. I'll be uploading that. You can ask that in the comments. Okay. So let us start now. And the question is, in a parallelogram ABCD, E and F are the midpoints of the sides AB and CD respectively. Show that the line segments AF and EC trisect the diagonal BD. So, what is the meaning of this question? This AF and EC trisect the diagonal DB means this DB is cut into three equal parts. That is, this DP is equal to PQ is equal to QB. Okay. So, we have to show that this DP is equal to PQ is equal to QB. How will we prove that? Okay. We'll see that now. First, this we know that this E and F, given that this E and F are the midpoints of AB and DC respectively. So, this AE is equal to FC, right? So, we can say that AE is equal to FC and we know that this CD and AB are parallel, which means this AE and FC are also parallel. So, AE is parallel to FC. So, what does that mean? AE is equal to FC and AE is parallel to FC means this is a parallelogram. So, this AEFC is a parallelogram. Okay, so we got this AEFC as a parallelogram, which means this PF, we have marked this P and Q here. So, this PF is parallel to QC, right? PF and QC are parallel. So, taking triangle DQC, take triangle, considering triangle DQC, consider triangle DQC. So, this PF is parallel to QC. So, by converse of midpoint theorem, we can say that this P is the midpoint of DQ, right? So, P is the midpoint of DQ by midpoint theorem. Okay, so this P is the midpoint of DQ, which means this DP is equal to PQ. If P is the midpoint of DQ, we can say that DP is equal to PQ. So, DP is equal to PQ. Okay, now we have to show that this PQ is equal to QB. Then we will get DP is equal to PQ is equal to QB. So, take this triangle ABP. This triangle ABP. Here, since this is a parallelogram, AEFC is a parallelogram, this AP and EQ are parallel. So, AP is parallel to EQ. So, taking this triangle APB, we can say that if EQ is parallel to AP, by converse of midpoint theorem, we can say that E and Q are the midpoints of AB and BQ, right? So, if EQ is parallel to AP, we can, by converse of midpoint theorem, we can say that this Q is the midpoint of BP, right? So Q is the midpoint of BP by converse of, this is also by converse of midpoint theorem. Okay. So, by converse of midpoint theorem, we have proved that this Q is the midpoint of BP, which means this QB is equal to QP, or QB is equal to PQ. That is, this is equation 1 and this is equation 2. Which means this dP is equal to PQ is equal to QB. dP is equal to PQ is equal to QB from 1 and 2. So, this AF and EC trisects diagonal BD. So you understood what is the meaning of trisect. That is, this AF and EC will divide this diagonal BD into 3 equal parts. That is the meaning of trisect. Okay, understood? Next question is, show that the line segment joining the midpoints of the opposite sides of a quadrilateral bisect each other. Let us draw this again. A, B, C, D. So I have drawn a quadrilateral like this, A, B, C, D, and midpoints are P, Q, R and S. We have to show that these two line segments bisect each other. Okay, bisect each other means this will be equal to this and this will be equal to this. So if O is taken as the center, this OP will be equal to OR and OQ will be equal to OS. Okay. Now we are going to draw a diagonal like this, AC. Okay. And join this SR. Understood? So, if we take this triangle DAC, taking triangle DAC, consider triangle DAC. Here, this S and R are the midpoints of this AD and DC respectively. So, if S and R are the midpoints of AD and DC, by midpoint theorem we can say that this SR is parallel to AC and SR is equal to half of AC, right? So, SR is parallel to AC and SR is equal to half of AC by midpoint theorem. You can write S is the midpoint of AD because S is the midpoint of AD and R is the midpoint of DC. Okay, so we got SR is equal to half of AC and SR is parallel to AC. Understood? Now take this PQ. Okay, so taking this triangle BAC. This P and Q are the midpoints of AB and BC respectively. So this PQ is equal to half AC and PQ is parallel to AC. We can take this as 1 and this as 2. Okay, so we got SR is equal to half AC and PQ is equal to half AC and SR is parallel to AC and PQ is parallel to AC. From that we can infer that SR is equal to PQ and SR is parallel to PQ. This SR is parallel to PQ and SR is equal to PQ. So if we join this PS and RQ, we can say that this PQRS is a parallelogram, right? So, PQRS is a parallelogram. And this PR and SQ are the diagonals of the parallelogram. PR and SQ are diagonals of parallelogram. and the diagonals of a parallelogram bisect each other. So PR and SQ bisect each other. So we can write PR and SQ bisect each other. And in bracket you can write diagonals of parallelogram. Okay, understood? You can note this down. You can pause the video and note this down. Okay. Next question is, ABC is a triangle right angled at C. A line through the midpoint M of hypotenuse AB and parallel to BC intersects AC at D. Show that D is the midpoint of AC, MD is perpendicular to AC and CM is equal to MA is equal to half of AB. In this question, the figure is not given. We have to draw the figure. So, given that it is a right angled triangle and C, right angled at C, and the triangle is ABC. So ABC. Okay. So we can draw it like this. Now a line through the midpoint M of hypotenuse AB. M is the midpoint of the hypotenuse AB and parallel to BC. This is parallel to BC. Okay. Intersects AC at D. Intersects AC at D. Show that D is the midpoint of AC. We have to show that this D is the midpoint of AC. This we can prove directly because given that MD is parallel to BC, MD is parallel to BC. So taking triangle ABC, we can say that D is the midpoint of AC by converse of midpoint theorem. Okay, understood. So we have proved the first part. Now we have to prove that this MD is perpendicular to AC. How will we prove that? We know that these two lines are parallel, right? So this is the transversal and we know that this angle is 90 degree, right? Angle C is equal to 90 degree. So these two are co-interior angles. This angle angle MDC and angle C are co-interior angles, which means this angle MDC is equal to, we are proving 2, okay. So angle MDC is equal to 180 minus 90, which is equal to 90 degree because co-interior angles. Or we can write this angle MDC and angle C are co-interior angles. Okay, so this is equal to 90 degree, which means this is equal to 90 degree because this is a linear pair. So angle MDA is equal to 180 minus 90, which is equal to 90 degree because linear pair. So we got this angle ADM is equal to 90 degree, which means this MD is perpendicular to AC. That is, this is 90 degree. If this is 90 degree, this will be 90 degree. So MD will be perpendicular to AC. Okay, proved. Now third one, we have to prove that this CM is equal to MA is equal to half of AB. CM, if we draw this CM, it is equal to, this CM is equal to MA and it is equal to half of AB. We have to prove that. We know that this AM, since M is the midpoint, AM is equal to half of AB. M is the midpoint of AB. Right? So, just we have to prove that the CM is equal to AM, okay, or MA. For that, first let us take this triangle AMD. Okay, so taking triangle AMD, we have AD square plus MD square is equal to AM square, right? Because this is a right angled triangle, so this AM square is equal to AD square plus MD square. That is AD square plus MD square is equal to AM square. Now take this triangle, that is triangle CDM. Here CD square plus MD square is equal to CM square, right? Isn't it? So we can take this as equation 1 and this as equation 2. Okay. But we know that this AD is equal to CD. AD is equal to CD. Which means these two equations are same, right? AD is equal to CD and this is a plus MD square. So on the left hand side, this AD is equal to CD and this term is same. Which means this left hand side is the same. So we can say that this equation 1 is equal to equation 2, right? Which means this AM square is equal to CM square, and that means AM is equal to CM. This AM is equal to CM. So we have proved that AM equal to CM, and we have first itself we have proved that this AM is equal to half of AB. So this is equal to half of AB. Hence proved. Hence we have proved that CM is equal to MA. Here we have to prove that this MA. CM is equal to MA or AM. So MA is equal to CM is equal to half of AB. You can write CM is equal to MA is equal to half of AB. Okay. Understood? You can pause the video and write this down. Okay. With this, I am winding up this video. I will be uploading questions from other chapters in the next videos. So stay tuned. And if you have any doubts, you can ask that in the comment section. Okay. And please don't forget to subscribe. Thank you and bye.